Hello everyone, my name is Mradul Kumar Jain, Assistant Professor in Ajay Kumar Garg Engineering College. Today we will discuss sets and its representation and its types. And we will start from the set. What is the set? Set is a well-defined collection of unordered distinct objects. Or we can say set is a unique unordered collection of objects. In the set, if you are making a set, all the elements of set will be written within the curly bracket separated by comma. Suppose, for example, you can see S is a set and having three elements A, B and C. That means this set contains three elements. So, and the definition says the elements should be well defined and it should be unordered. What does it mean unordered? If suppose I am writing S is equal to a set 1, 2, 3, the same set can be written if the elements are 2, 3, 1 or S equal to 3, 2, 1 or in any order. Whatever order you can use, the set will be the same. These in this condition, the set S is the same. So, order is not necessary to maintain for a set. Next thing we are saying, it should the number of elements in a set, the number of elements, suppose this set contains 3 elements, so we can say the n of S is equal to 3. This set contains 3 elements. Next thing is, if we are saying all the elements of the set should be distinct. So, if there is a set and it contains elements like this 1, 1, 1, 2, 2, 3 and 3. So, you can see that this set contains 8 elements and the element 1 is repeated 4 times and 2 is repeated 2 times and 3 is repeated 2 times. So, this when we see this set, it contains 8 elements, but we are saying the set must contain the unique elements. So, this set is exactly same if it contains 1, 2 and 3, because the repetition of elements should be counted on only one time. So, repetition of elements is allowed. If there exists repetition of elements, then it will be counted 1. So, multiple frequency of the same element will be counted 1. Next is, we have different type of sets. Suppose I am talking about a set of all the states in the India. So, you have to write all the states, 36 states including 8 territory states, you will create a set. This is a set. And suppose I am talking about the set of lowercase letters. So, you will write all the elements starting from A to Z in small letters or the lowercase. Some other sets are the set of whole numbers. The whole number will start from the 0. So, and after 0 you will count as the next number will be the 0, 1, 2, 3 and so on up to infinity. The set of natural numbers. The set of natural numbers start from the 1. So, the elements will be the 1, 2, 3, 4, 5 up to the infinity. The set of integers, it contains the negative elements, negative numbers, 0, then positive integers. And if I am talking about only the positive integers, then it will start from the 1. So, it contains 1, 2, 3 up to the infinity. Then set of rational numbers. Rational number means what? A number that can be written in the form of P upon Q, where Q should not be equal to 0. And the set of real numbers, set of complex numbers. So, these are different types of numbers that can be represented in the form of sets. And you can, the major observation is, this is the set, you can see, that means the set of complex number is the highest set, having the largest set of number of elements this complex number have. So, you can see n is a subset of whole numbers is a subset of integers, integer is a subset of rational numbers, and rational number is a subset of real numbers, and real numbers is a subset of complex numbers. So, this is the largest set in these set, if you will compare all these sets of numbers, you can see the set of complex number will be the highest set, having the highest number of elements. So there are two methods by which you can represent the set. So these two methods is, one is the roster method and second is the rule method, or it is also known as the set builder method. So in the roster method, in the definition I have already told you that if you are writing the elements for a set, it will be written in the curly bracket separated by comma. So this is a set A having 5 elements 1, 2, 3, 4 and 5. This is another set B having this is the set of vowels having 5 elements A, E, I, O and U. In the second method, rule method or the set builder method, you can see that if you want to write a set, if you want to write a set and you want to written in the form of set builder method, so the method is, you have to write A, you have to write the element will be written in the form of A equal to X, and you will write the property of this X element. Okay, so you have to maintain this definition, you have to maintain this property. So suppose you are writing a set in set builder form, that means there is a set A, it contains X type of element, and what is the definition of X, or what is the property for the X for which you are creating a set? That means this X belongs to Z, X belongs to integer, and this integer lie between 0 and 6. So that means this particular set contains 5 elements 1, 2, 3, 4 and 5, because X belongs to Z and X lies between 0 to 6. 0 और 6 के बीच में मेरे कौन से एलिमेंट आएंगे? 1, 2, 3, 4, 5. So if you can generalize the set, or you can create the property, or you can create a definition for your numbers, it is better to maintain or to write the set in the set builder form. If there is limited number of elements, 2 or 3 elements, then you can use roster method, otherwise you can use the set builder method. Next is the universal set. A universal set denoted by U, capital U, is the set of all possible elements used in a problem. Whatever the number of elements you are using in the problem, all the elements should be considered as a universal set. Suppose I am talking about there is a set set of integers. So this is the positive set of positive integers, and this is the set of negative integers, and the universal set contains all the integers. So we know that the integer contains all the negative values, all the positive values and 0. So where will be the 0? So 0 exists in this set. Okay, then it will be a complete set or the universal set. So if you will consider all the possible elements, then it is called the universal set. The second is subset. What is subset? Suppose we have two sets. One is set A and second is set B. The definition of subset will be if each and every element of set A, each of every element of one set, in this case the set B, if this is the element of set A, the definition says if each and every element of one set belongs to the another set, then it is called subset. So you can see in this example, 2 belongs to A, every element of B belongs to A. So 2 is a element of A, 3 is a element of A. So we can say B is a subset of A. In such a case, we can say B is a subset of A. In the special case, when there is a set C and it contains all the elements which are in A, 1, 2, 3 and 4 and 5. So you can see each and every element of C, one belongs to A, 2 belongs to A, 3 belongs to A, 4 belongs to A, and 5 belongs to A. So each and every element of element C is belongs to set A. In such a case, we can say C is a subset of A. If two sets are equal, because in such a case you can also write okay, A is a subset of B or B is a subset of A. The both identity will follow. You can write either is A is a subset of B or B is a subset of A. You can write in both way, because you can see okay, each element of A belongs to C and each element of C belongs to A. Only this is a condition. This is a special condition that it still holds in for the subset. Otherwise, the set having the less than element of A, any less, there may be the 1 or 2 or 3 or the 4 or the 5 elements may be the missing. So we can say there is a special subset. There exists a special element which is called the phi, always the subset of each and every set. Suppose you are suppose we have three there is a set S having 3 elements 1 to 3. So we have to write the all the subset of this particular set. So how we can create this particular, how we can write the all the subset of this particular set. So first we will create or we will make the element, we will make the subset having 0 element. So I have already told you a set having 0 element is known as the empty set or the null set. It will written by the phi. So this is the first element phi. Okay. Then you will create the subset having 1 elements only. So in such a case you will create these 3 elements 1, 2 and 3. Then you will create a subset having 2 elements. Then you will write 1, 2, 1, 3 and 2, 3. Then you will write, then you will create a subset having 3 elements, because in our set having 3 elements. So first we will create the subset having 0 element, then we will create a subset having 1 element, then we will create a subset having 2 elements. Then in the last we will create a subset having 3 elements, because in our set the maximum elements are 3. So we will go up to the 3. So you can say, you can see this the set all we have create all the subsets and the counting is 8. So if there will be 2 element, if there is a set S and there is only 2 elements, then you will create a set having 0 element phi. Then you will create a subset having 1 element. Then you will create a subset having 2 elements. So these are the subsets. So if there are 2 elements, the subset is 4. If there are 3 elements in a set, then subset is 8. So how we can generalize how many subset can be possible if there are n elements? So if there is 2 elements, the subset are 4. If there is 3 element, subset is 8. If there are n elements, then how many subset will be possible? Because it can be represented by 2 square, it will be written by 2 cube, because there were 2 elements. In such a case there were 3 elements. If there were n elements, then the subset will be 2 to the power n. And how you will you can calculate? This is very simple. First you will create all the combination having 0 element, then you will make a combination or you will create all the subset having 1 element, then NC2 having 2 elements, then NC3 3 elements, and so on. So if there are n elements, then the same sequence will go up to the NCN. And what does it mean? this is the binomial expansion of 1 plus 1 की power n. So this is equal to the 2 की power n. So we can generalize this method that if there are n elements in a set, the how many number of subset are possible? It is 2 to the power n. Next is empty set. In the previous slide I have given you a little bit idea. If there is a set having no element, that means set doesn't have any element, this set is known as the empty set. Okay. Second is the singleton set. As the name suggests, single. So that means a set which contains only one element, this is called singleton set. For example, suppose I have mentioned a equal to 3. This set contains only one element. The set B, it contains a special character @ So that means it also contains the single element. So these two sets are the singleton set. Okay. So there may be different number of different type of singleton set. Suppose I am saying there is a set of prime numbers with having even value. So that means there exists only single value 2, which is even and the prime. Okay. So these are the examples of singleton set. Next is the finite set and infinite set. So as the name suggests, a finite set, if a set contains finite number of values, then it is called finite. If the set contains infinite value, or if the value is not finite, then the set will be the infinite set. So for example, if a is equal to 3, 4, 6 and 8, so this is the it contains only 4 value, so this is the finite set. And a set of natural numbers, it will start from the 1. So you will start from the 1, 2, 3, 4, 5 up to infinity. So how many numbers exist in this set? This is infinite, it will go up to the infinity. Same if I am talking about the integers, the interval of integers will be the -infinity to infinity. Again it contains the infinite numbers. So this set will be the infinite. The set of whole numbers, real numbers, rational numbers, complex numbers, all are the infinite set. But if we are talking about the infinite set, again infinite sets are of two types. One is countably infinite set and second is uncountable infinite set. It is important. It is different, and you have to use your own wisdom to understand this particular set. First is infinite countable and second is infinite uncountable. Okay. So what is the definition of infinite countable set? A set is called infinite if you can map these elements one to one with the natural numbers. What does it mean? If we are able to map the elements of a set with the natural numbers, the set is infinite. I have already told you that these countable and uncountable sets are used with only infinite words. So if the set, you can map these numbers with the infinite set or the given set, you can map with the natural numbers, this set will be said at the countably infinite or infinite countable set or the countable set. Okay. So for example, set of integers, you know this integer will start from the -infinity to infinity, and you can write like -3, -2, -1, 0, 1, 2, 3 up to positive infinity. So we have to check that we can map these elements with natural numbers or not. So suppose I am mapping these elements. Suppose when I am talking about the natural numbers, I have to map these numbers with the natural numbers 1, 2, 3, 4, 5 up to infinity. So I will start from the 0. I will map it with 1. Okay, and I will map 1 with 2, -1 with 3, 2 by 4, -2 by 5, 3 by 6, -3 by 7, and so on. So I will map all the elements, these infinite elements, with natural numbers. Possible in this set for the integers which contains the positive values 0 and the negative values, I can map these elements. We can map the all the integers with natural numbers. If you can map the numbers, then this type of set is called infinite countable set. The second is uncountable infinite set. If you cannot map it one-to-one mapping from your given set, your given infinite set with the natural numbers, you cannot say, or you will say this is uncountable infinite set, because you are unable to map it with the natural numbers. For example, suppose again the real numbers, the example the real numbers, and you know the real numbers will again minus infinity to infinity. So I am talking about a very small set 1.0 to 2.0. So how many number exist between 1.0 to 2.0? The important thing is this. So in the case of real numbers, you can imagine, you can visualize the number which are exist between 1 and 2 is the infinite. Between two numbers there exist infinite numbers. So if you will try to map it with the natural numbers, all the natural numbers will consume between these two numbers. All the natural numbers you will consume between these two numbers, and still the set is a large. There exists a large number of real numbers. So that means in such a case it is not possible to map these all real numbers with natural numbers, because you are consuming all the natural numbers between two numbers. Getting my point? So it is not possible in such a case. That means set of real numbers is infinite uncountable set. Next is the cardinality, cardinal number. The number of elements in a set is called the cardinality. Suppose there is a set A, it contains 5 elements, then how you will write the cardinality? The number of elements in set A. The number of elements in set A, this is 5. If I am talking about the proper subset, I have already told you the subset, the definition of subset. There is a very little difference between proper subset and subset. If I am talking about, if B is a subset of A and B is not equal to A, B is not equal, these two sets cannot be equal, then in such a case we can say B is a proper subset of A, proper subset of A. That means the case where the two subsets are equal, it cannot be possible. Two sets are in the definition of subset. When we are saying the set A contains 1, 2, 3, 4, 5, and I have made the set C which contains the 1, 2, 3, 4, 5. This type of condition, only this type of condition cannot be held by the proper subset. Otherwise, the proper this is a very hairline difference between proper subset and the subset. So, and the subset sign is this much. So we can say B is a subset of A. In such case, B cannot be equal to the A, or we can say A cannot be equal to B. But in the case of subset, it is possible. Equality of set. Suppose there are two sets A and B. Then if I am talking about these two sets are equal, A equal to B. If you want to ask how you will prove these two sets are equal or not. So there is only one condition. You have to prove that A is a subset of B and B is a subset of A. Only this is the condition. When you will prove this is the condition, A is a subset of B and B is a subset of A, then you can say these two sets are equal. For example, there is a set A which contains m times m type of element and m belongs to Z, integer. And what is the definition of m? M is equal to 2k plus 3. And the set B contains all the set of all integers. So if you will create this set and you will write some different value of k, then you will find that you will get the set. Suppose you will write the value of k starting from -3, you will get -3, minus 2, minus 1, for different value of k, you will get this set. Sorry, it will not be given by this, no, or this will be not. It will provide you the only the it will provide only you the odd numbers. And if you will find the set of all odd numbers, what will be the odd numbers? Minus 3, minus 1, 1, 3. This is the set of odd numbers, odd integers. Okay. So you can say in such a case, we can suppose this is a set A and this is a set of B, and from the set it is very clear, set A is a subset of B and B is a subset of A. If this condition hold, then we can say A equal to B. A equal to B. In two, when you will write different values of k, if you will write minus 3, it will give you the minus 3. If you will put k is equal to minus 2, it will give you the minus 1. If you will write the k is equal to minus 1, it will give you the plus 1. If you will write the next value, then it will give you the 3. So you are getting the same set, and you can say for these two sets, A is a subset of B and B is a subset of A. So we can say A equal to B. Different type of set properties, especially there are some property that you can remember for the empty set, because what is the empty set? If there is no element in the set, then it is called the empty set. So, and it is represented by phi. So always I have told you in the power set definition that phi is always a subset of A. There is always exist a phi for each and every set. If you will take the union, that means you have to write all the elements which are in A and phi, and there is no element in phi. So if you will write all the elements which are A and in phi, it will be equal to the A. If you will take the intersection, that means you have to write the common elements which are in A and the phi, but there is no element in phi. So what will be that means there will be no element will be common from in A and phi. So the result will be the phi. If you are taking the A intersection of A complement, again, because this is the A and this is A complement, outer boundary, this is the A complement. So number of common element will be, there will be no common element between A and A complement. So this is again phi. Disjoint set, if there are different sets and there is no element in common between these two sets, then this is called disjoint set. Suppose this is a set A, this is a set B, no element is common. So you can say in the definition, if AI intersection AJ, if you are comparing two sets, then there is no element is common and I is not equal to J. In such a case, this type of set is called disjoint. For example, A is equal to 1, 2 and B is equal to 3 and 4, and you will see, you can check the common element, there is no common element exist between these two sets. So these two sets are disjoints. Similarly, if you will write the set of even integers or set of odd integers, again there will be no element in common between these two sets. So again it will be called as disjoint set. Power set, I have already when I was creating the definition of subset, that I have already made all the sets of 1, 2, 3. Okay. So in the power set, again it is the same. When a set of all subset is known as power set. So I have already created all the subset in the definition of subset. So here you can say, if you will write all the subset in a set, it is called the power set. So I have already proved at that time it contains 2 to the power n elements. Okay, thank you.